Okay, you should have already received something from me about an ASC Test 3 review. Everybody get that? Did I send that out? Oh, okay, maybe I sent statistics and didn't send yours, but I'll check into it, make sure that you have that, okay? There is an ASC Test 3 review. They do record. You can attend it live, virtually live, or you can watch the recording, and I'll make sure I get that posted for you, okay? If I haven't already, and if some of you get back there and you're looking for it, be sure to send me a course message, and that'll help me to remember to do it if I forget, okay? But what I've got for you is a really good review, because I went through and worked this one out and really kind of went by your actual test when I was doing it. So this one does give you an indicator of the types of problems that you're going to be looking at. What I'm going to suggest that you do is to work these problems out and then work them again. Maybe write them down on a separate sheet of paper. If I have extra copies over there, you can pick them up. It should also, I usually post this to your Blackboard. I post it for the online classes, so I'll try to remember to post this for you so you can print it again if you want another copy and use it like a practice test before you come in here so that you are covered with all the different types of problems, okay? Because basically that's what this is. And we've reached the point where you really just need to recognize the type of problem you're working. For most of you, the math is not that hard. It's just, where do I start? What type of problem is this? And so anyway, that's what I'm hoping to help you with today. The first one, of course, says just to, and guys, in these tests, one of the most important things is read the directions, okay? They give you tremendous hints in the directions to the problem. This one says factor out the greatest common factor. That is all you are required to do for this problem, okay? You don't have to try to factor it further when it just says factor out the GCF. So what we're looking for is something in this trinomial they have in common. 4, 8, or negative 8, and 16 have a factor of 4 in common, so I have a GCF of 4. If I look at the x's, the smallest exponent is a 6, so I have a factor of 4x to the power of 6. Now, when you factor it out, you have something left over. So basically what you're doing, any way you want to do it, if you want to write it down and divide it, you can. Or if you want to say 4 times what is going to give me 4, well, 4 times 1, x to the 6 times what? Well, it would be x squared to get back to x to the 8th. Or you can divide. However you want to do it. You would divide each term by 4x to the 6th. This one, of course, is going to be a negative 2x, and this one is going to be a positive 4. So when I factored out 4x to the power of 6, that's what I got. That's all I'm required to do. I don't even have to look at that trinomial to see if it will factor further, because it said factor out the GCF. Now the next one says factor by grouping. Well, typically, when you have a problem that has a polynomial with 4 terms, you factor it by grouping. But then it's really nice when they tell you so you don't have to guess. Now, this one, I just want you to note, the middle operation is negative, which makes this the tricky one, okay? So we group the first 2, and we group the second 2, and we leave that negative inside the second group. Add a plus sign in there just so that you'll know that that's not multiplying 2 binomials together, right? When I look for a GCF in the first group, I see that they have a common factor of A. So I'm going to factor out A. And what I have left is C plus 9. In my second group of trinomials, if the first term, when you're factoring, if the first term is negative, you are required to factor out a negative. So we will have a minus something, even if it's just minus 1, okay? And I'm going to say minus, and both of these have 2 in common, so I'm going to factor out a common 2, negative 2. What do I have left? Well, both of these terms were negative, but when I factor out a negative, it changes the sign. They both become positive. So I will have a positive C and a positive 9, which matches. Hint, hint, when you're doing grouping, you look for that to happen, okay? So I've got that common C plus 9, and I've got the second binomial is everything else. Look, everything else, A minus 2. That's my second binomial, and that's factoring by grouping. Okay, number 3, factor the polynomial, the trinomial, and it doesn't tell us where to start. So where do you always start? GCF. You look for a GCF. So I look at this and it's got, well, 2, they're all even numbers. I know I can factor out a 2, and 2 is the biggest coefficient and smallest coefficient I got. So I'm going to say this is 2 times something. And that trinomial, I'm not changing any of the signs. If you wanted to, you could go ahead and put the signs in, couldn't you? It's going to look like that when I get the 3 terms in there. So I'm going to factor out 2. This first one is going to be y squared. I'm going to factor out a 2. Well, that next one is going to be a negative 5y. I'm going to factor out a 2, and that one is going to be 6. Basically, I divided each term by 2, didn't I? When I say 2y squared divided by 2, I get y squared. You understand, right? I'm not repeating that too much anymore because you've had enough practice doing it by now, right? Okay, so I look at it and I say, okay, I have to say, it didn't tell me just factor out the GCF. I might not be finished. I have to see if this thing will factor again. So I'm going to try it. I'm going to write down the binomial pairs that I would normally factor a trinomial, not forgetting the GCF. And I'm going to look at that second operation, which is plus. It tells me to use the first operation for both of them. I'm going to factor that y squared, because that's done. All I'm missing now is these 2 numbers. And I can come over here with my x puzzle, and I can say, well, that's a times c. Well, that would be 1 times 6, right, up here. Down here is the b coefficient, which is a negative 5. And then I'll come over here with my sides, and I want to make fractions. I'm sorry, should be y. And I'll put the y's, you know, in there, because that's where I begin, isn't it? And then I want factors of 6 that, when combined, will give me a negative 5. And I know that both of them have to be negative, right? So I know they both have to be negative. Well, it's going to be 1 and 5. Negative 1 and negative 5 will combine to give me a 6. Saying it all wrong. Will multiply to give me a positive 6, right? And so what I'm going to do over here is I'm going to go, okay, sorry guys, I'm not even thinking straight. Won't combine to give me the 6, but I'm going to have to go to the next one, right? Negative 2 and negative 3. Multiplied together, they'll give me the positive 6. Added together, they will give me the negative 5. Sorry, thinking of something else this morning. Are you okay? Good. All right, so I come over here and I go negative 2, negative 3. And this factor becomes y minus 2, and this one becomes y minus 3. Now, when you factor a trinomial, you FOIL it to check, okay? So I'm going to say y times y gives me y squared. Negative 2 times negative 3, positive 6. And when I do these inside terms, I say that comes out to be a negative 2y. Outside, that comes out to be a negative 3y, and I combine them and get a negative 5y, which is my middle term. If you had made the mistake that I made at the beginning, this would catch it, okay? You would catch it when you FOIL to check. You go, oh, wait a minute, that's not right. I must have done something wrong. Go back to where you actually factored that 6. Are you good? Okay, don't forget the FOIL to check part. In fact, I'm going to be looking at your test papers, your written work. I told you I'd be looking at your work to see if there's any extra credit or any partial credit I can give you. And I'm going to be looking for this to see if you FOIL to check it. If there's extra points to be awarded, it's going to be here, all right? To see if you did the little check marks, if you added the 2 inside and outside together, that would be your opportunity, okay? All right, factor the trinomial. Well, this one looks like it's got to have a GCF, right? It's just got such big numbers. And the first thing I always want to go is, well, 8. Will 8 factor into all 3 of those? I mean, is 8 a factor? Well, 8 is a factor of 8, but it's not a factor of 36. So I got to go down, and I would go down to the next biggest factor, because I know they're all even, right? 2 will work. But let's try 4. And when I say 4 will factor into both of these, I'd have to probably take my calculator out and say 56 divided by 4. That's not hard, though. You can actually do it pretty quick, can't you? So So I'm going to go 56 divided by 4, and I come up with, yep, it's 14. So I'm going to factor out a 4. 4. And I can also factor out an x, because they all have an x. And when I do that, I know I've got 3 terms in this trinomial. I know I haven't factored out a negative, so those signs stay the same. I say 8x cubed divided by 4x. Well, that gives me 2x squared, doesn't it? And then I say 36 divided by 4 is 9. X squared divided by 4 is x. I say 56 divided by 4, well, I just did that when it was 14, wasn't it? And x divided by x just gets rid of it. So that, look at it again to make sure that we got all the GCF out of it, but I see nothing in common now. But am I finished? You don't know that you're finished with this one until you try to factor the trinomial. So this plus sign of the second operation says use the first one for both. I'm going to go ahead and factor that x squared because I know it goes to x times x. And then I'm going to come over here and do a diamond. I'm going to say that top part of the diamond has to be a times c, which is 2 times 14, which gives me 28. The middle is the b term, which is 9. And this time, I'm putting 2x, because I always use the coefficient. I might have to reduce this, so I'll use the coefficient. Now, I want factors of 28 that when they're combined, they're going to give me 9. I know they both have to be positive, right? Both of them have to be positive. So I'm going to start. I don't really see it, so I'll start. I'll go 1 and 28. That doesn't work. 2 and 14, right? That doesn't work. 3. Will 3 divide into 28? Well, it's 8 plus 2 is 10. That's not divisible by 3, so 3 won't. But 4 will. 4 and 7, right? They're not going to add together to give me 9. I'm kind of going to look at 5 and say, nope, that won't work. Does 6 go into 28? Anybody? Okay, 7, we already did that, right? I mean, I'm kind of done, right? Do you see anything else? None of these work. Therefore, this thing doesn't factor anymore. And what do you do there? You stop right here, okay? But you must check it. You must look to see if it factored, okay? But that's your answer. All that was able to be factored out of that one was a GCF. Okay. Next, we have a trinomial down here that looks like it does not have a GCF, so I know I'm going to set up my binomial pairs, and that second operation is negative, so it says I have to use one of each sign. And then I'm going to go ahead and factor the x squared, and then I'm going to set up my diamond, okay? This one's kind of got big numbers. 4 times negative 20 is the top. A times c gives me a negative 80 up here. The middle term is 11. And what do I put here? Well, I put the x, but I also use the coefficient of that a term, which is a 4, right? Sorry, can you see it better now? And then I'm coming over here, and I'm going to say, oh, sorry. Just this morning, I was working on statistics before I came in here, and I can't seem to switch gears to get to algebra. Sorry. But anyway, I've got negative 80, and I want factors that will, combine. One is going to be positive, one's negative. So it's going to be a kind of a subtraction thing. So I'm combined to give me 11, and I don't see them right away. And if you had to start at the beginning, you'd say 1 and 80, 2 and 40, and 3 doesn't work, but 4 does, right? 4 and 20. Still, no way that any of those are going to subtract to give me 11 yet. But 5, okay, I don't know what 5 is, so I'm going to go 80 divided by 5, okay, 16. That's the winner, isn't it? Okay, when you can't see the board, and when I'm not writing on the board, somebody tell me, okay? I have to shrink it down sometimes, okay? So 5 and 16 one of those will subtract. I need a positive 11. So the bigger one has to be positive, doesn't it? I need to say 16 minus 5. Okay, so I'm going to put a negative 5 and a positive 16. And then I'm going to reduce them if I have to. Well, this one doesn't reduce. The 4 and the 5 don't reduce. So I'm going to say this one that has a negative is really 4x minus 5. This one will reduce. Let me take it a little step further. I can divide both of those by 4, and I would end up with x over a positive 4. So that would be my other term over here. Now I have to FOIL it to check it. So I say x times 4x, that's 4x squared. And I say 4 times negative 5, that's negative 20. You're almost always guaranteed that you're going to get the first and the last correct, okay? Almost always. Here's where we do run into trouble. When we say 4 times 4x, that gives me 16x. And then I say negative 5 times x, negative 5x. And I end up with 11x, and that checks. Okay? Okay. Let's go to the next page. So far, you good? So far, this is not going to be hard, right? All right, the next one. It looks like 81b squared minus 16. You still have to look for a GCF. Even if you're looking at that thing and saying, you automatically recognize that it's a difference of 2 squares, you still have to factor out a GCF first, or you will have the answer wrong. Okay? There will be GCFs inside those binomials when you factor them. But I'm looking at 81 and 16, and I don't see anything. Anybody? So we're going to factor this as a difference, which is the subtraction in the middle of 2 squares. Remember what that one is. Perfect square, subtraction in the middle. And also remember that a sum of 2 squares will not factor. A sum of 2 squares is prime. Okay? If this was the same problem but it had a plus sign in the middle, you could not factor it. Are you with me? Unless there was a GCF that would come out. So this time I'm going to say the easiest factoring problem there is, right? One of each sign. Square root of the first term. Well, the square root of 81 is 9. Square root of b squared is b. Now I use that for both of the first terms in my binomials. Then you say square root of the second term over here. Don't worry about the sign. You already fixed the signs, right? And that's it. And guys, I don't even require you to FOIL to check this one. It's too simple, right? This is the easy kind. The easiest factoring problem you have is a difference of 2 squares. One of each sign, square root of the first term, square root of the second term, you're done. Any questions? Wish they were all that easy? Yes? I do too. Okay, let's get the next one. This one, pay attention to the directions. Like I said, I've gone through your test and I've come up with these hints for this worksheet so that you will see a test very much like this, and it's going to use these words. Be sure you read your directions. It's going to say things like solve. If it says solve, you have an equation. We haven't had an equation to this point. This one has an equal sign in it, and it has to be set to 0 in order for us to solve it. So after you finish factoring, you're not done with the problem. This is what happens to me every time on this test. People finish factoring it and they quit. They don't give me the rest of the problem. They miss it because they didn't finish it. You're not going to do that, right? Tell me you're not going to do that, because I'm not going to be here Monday, and I think my dean is actually going to be doing your test for you. Very nice person. You'll like him, okay? But anyway, he's not going to remind you of this, okay? So let's do, how do we factor? I'm going to look at these 3 and say, do I have a GCF? Well, the only GCF I could have would be 3. And you see why, because that last term is a 3. Is 84 divisible by 3? Yeah. 8 plus 4 is 12. 12 is divisible by 3. 84 is divisible by 3. I don't know about you, but I would probably go 84 divided by 3. Okay, it's 28. I'm going to factor out a 3. I have same signs in this binomial. I'm not going to forget to write it down as equals 0, because that's going to help me remember to solve it. And then I'm going to say, okay, what was it, 28? 28x squared. Factor out the 3 of the middle term. What do you end up with? 3x. Factor out the 3 of the third term, negative 1. Everybody good with that one? Okay, so now we have to factor again. We're going to say 3. I'm going to set up two binomials. I'm going to set them equal to 0. That negative in the second operation says use one of each sign. I'm going to factor the x squared, and I'm going to go over here and set my diamond up, or X puzzle, what you want to call it. Okay, so 28 times negative 1, negative 28. Middle operation, or middle term, is 3. And then I'm going to come over here and say I need a 28x and a 28x, because I want the coefficient of whatever that a term is in case I have to reduce it. So I need factors of a negative 28 that when I combine them, they're going to be a 3. I know I'm going to have one of each, so it's going to be a subtraction sort of thing that I got to think about. And I start off with going, I don't know if you see it, so I'm starting from the beginning and going 1 and 28 won't work. 2, 14, that's not going to subtract anyway. I can subtract it to get me a 3. A 3. So 3 will not divide into it, but 4 and 7, if I subtract those, I can come up with a positive 3. If I say 7 minus 4, it'll be a positive 3. So I got it. Minus 4 plus 7, right? Now these will both reduce. I can't use these factors as they are because 28 and 4 can both be divided by 4, right? If I divide 28 by 4, I have 7x. If I divide negative 4 by 4, I have negative 1. So that's my first factor. I'll put it over here where I wrote the negative one. And then this one, I can divide them both by 7. 28x divided by 7 is going to give me a 4x. And 7 divided by 7 is, of course, just a 1. So that second factor is going to be 4x plus 1. Now we have to check it. Ignore the 3. Go here and say 4x times 7x squared, 28x squared. 1 times negative 1, negative 1. And inside terms, here they are. I'm going to write it over here. That's going to be a positive 7x. And outside terms, that's going to be a negative 4x. And when I get those combined, I'll have a positive 3x. So I did it right. I'm good. But I'm not finished. This is where some of you will forget to go on, okay? Are you listening to me? You have to solve this one. So we have to set each of these factors to equal 0. Well, when I say 3 is equal to 0, there's no way that's going to work, right? So that one is not a factor. But that's the GCF, and I do have to check the GCF. And then when I say 4x plus 1 equals 0, well, that was not really easy for me to see right away what the solution for x is. But I'll subtract 1 from both sides to get going here. And I have 4x is equal to a negative 1. And then I'm going to divide both of these by 4. And x is going to equal a negative 1/4. That's one solution, isn't it? Okay, next one. 7x minus 1 is equal to 0. I'm going to add 1 to both sides to get this x term by itself, and I'll have 7x is equal to 1. Dividing both sides by 7 now, I'll have x is equal to 1/7. Those are my two solutions, right? Negative 1/4, positive 1/7. Any questions on that one? You good with this? You've done a lot of my lab math, haven't you? Haven't you solved a bunch of these already? Okay, next one says also solve. Please circle the word solved when you see it so that you don't forget to finish the problem, okay? This one, however, is not set equal to 0, so we are not able to do this until we get it equal to 0. I will have to subtract 10 from both sides to make that happen. I hate the way this paper printed, so I'm coming over here to write it. I'm going to say x squared minus 9x minus 10 is equal to 0. I wrote it in the form that I want the trinomial in when I factor it, you know, highest exponent to the smallest. And I'm ready to factor because there's no GCF. So I say, well, this is a negative in the second operation, which says use one of each. X square factors easily. I've got the simple trinomial, so you might not even have to draw the puzzle over here to do this one. 1 times negative 10 is negative 10, and the middle is negative 9. And then I want x at the top of each of my factors, or each of my sides. And now I say I want factors of negative 10 that when they're combined, they're going to give me a negative 9. It's going to be a subtraction thing because one's going to be positive and one's negative, right? So 10, what about 1 and 10? Yep, if it's a negative 10 and a positive 1, it would be 1 minus 10. That would give me negative 9. So I got a positive 1, a negative 10, positive 1, negative 10. I have to FOIL it to check it. X times x is x squared. 1 times negative 10 is negative 10. Inside, 1x. Outside, negative 10x. That's going to give me a negative 9x. That's where, if you are doing this and you're wanting extra points, this is what I'm looking for, okay? To see that you did the FOIL to check. And then we set each of these equal to 0 so that we finish the problem. This one's easy. Subtract 1 from both sides, right? Write it down if you don't see it right away, like we did in the other one. Add 10 to both sides. And my two solutions, x is equal to negative 1, and x is equal to a positive 10. Are you good? Because we're changing gears. We're going to something different now. Okay? The next part, we're going to use the square root property. Like I told you, these are really good hints. Use the square root property to solve the equation. What that means is you've got to have something that is squared on one side, everything else on the other side. This one has 3x plus 2 squared, and it's equal to whatever. We don't care. Okay? So how do I do the square root property? Well, I take the square root of both sides. When I take the square root of this one and the square root of that one, then I can solve it. What's the square root of something that's squared? Well, we simply get rid of the square, don't we? It comes down to whatever it was. What's the square root of 27? That is not so easy for us to do because it's not a perfect square, is it? But there is a perfect square inside 27. So I look at 27 and I say, really, this is the square root of 9 times 3, right? And 9 is a perfect square. I can bring out the 3. The 3 is I can bring out the root, which is a 3. The 3 that stays under the radical is that part. Now, sometimes, guys, we've written it like this. This part comes out. This part stays, okay? Whatever it takes, whatever notation you need to make sure that you got it clear. So over here, I didn't do anything. I've got 3x plus 2, and it's equal to, I brought my 3 out, so it will now be multiplied times what's left under the radical, which is the square root of 3. Remember, when you bring it out from under the radical, it has to get multiplied times that radical, okay? It's not added to it, it's multiplied. You good there? Yes? Okay, so now I can start to solve this. Okay, granted, it is messy. This one's not neat and clean, and everything's not resolving, and I don't have just numbers. So just deal with it. What are you going to do? You're going to treat that square root of 3 just like it is a variable, okay, like it's a y or something. What would you do if it was just a plain old y? Because it can't change. We can't find the square root of 3. So what we do is we say, okay, I'm solving for x. So I got to get rid of this plus 2. I'll subtract 2 from both sides. And I've got 3x is equal to, well, now see, I'm going to put it in first, negative 2 plus 3 times the square root of 3. You could have said 3 times the square root of 3 minus 2, and it would have been fine. Either way you want to do it. Okay? Yep. All right, now what do you do to solve for x? Divide by 3. So when I divide that by 3, look, I have to divide this entire side by 3. Okay, let's rewrite it because it's a mess, isn't it? Let's say over here the 3's cancel. I have x. What does this side look like? Well, it's a negative 2 plus 3 times the square root of 3 over 3. Can I simplify that? Will that 3 reduce with the numerator? Okay, so tell me why. Why not?
Doesn't everything in the numerator have to be divisible?
Yeah. This 3 is divisible by 3, but that negative 2 is not. And this is addition in here. Addition and subtraction changes things. You have to reduce each term in the numerator by the denominator if you're going to reduce it. And since these both will not reduce, this thing will not reduce. Yes?
In my math lab, it said that I had to put the positive and negative prior to the 3. So I was just curious how that factors into it.
Yeah. Thank you. Let me go back and say that again, okay?
Sometimes there was 2 answers to the solution.
When you're doing the square root, when you're saying the square root, you have a plus and a negative. And I was just so bogged down in this that I didn't think about it. So what we'll have here, I'm trying to think where to join it into your notes here, guys. Plus and minus. So what you'll have is plus and minus when you pull out the 3. Does that make sense? You've done that enough in my math lab, right? Okay? All right, next one. Let's go over here and say we're going to use the square root property. It would help me if I would look at my notes where I have the actual good solutions in there. And we're going to use the square root property to solve this equation. However, we don't have perfect square we don't have anything that's squared on one side and the answer on the other, everything else on the other. We have an x squared here, but we need to get that 169 to go to the other side, okay? Because we need a perfect square or a square equal to anything else. So all you're going to do here is say minus 169. X squared equals negative 169. Now I can say square root of this one, and I can say square root of this one, and the other thing that you probably should do over here is go ahead and add the plus or minus in front of that radical. Not for the x squared, because we're just going to get rid of it, right? But let's go over here and say this is plus or minus the square root of negative 169. And now what do you see that you need to do first? Square root of negative 1, right? So what is this negative 169? It's really equal to negative 1 times 169. And negative 1 comes out from under the radical as I, doesn't it? Okay, what about 169? Any perfect squares in 169? Yeah, it is a perfect square. It can come out from under the radical as a 13. I've got rid of my radical by doing that. So what I'm going to have here is x is equal to, well, you could write I times 13, but the way we usually write it is 13I, okay? I wouldn't count it wrong if you did I times 13, though. Okay? Okay, are you good? All right, quadratic formula to solve the equation. Now, I don't know how much you love the quadratic formula, but I find people all the time that instead of factoring, they'd rather just plug it into the quadratic formula. It's really not a good idea because factoring is quicker. And it is also, factoring is less prone to errors. The quadratic formula is prone to all kinds of errors in it. Everybody makes a lot of mistakes, so be careful when you're using it. Do you have it memorized? At this point, write it down on your test paper just to see if you have it memorized. Because, like I told you, your test is going to be probably proctored by my dean, and he will not remember to give you that quadratic formula. In fact, I think the math department has decided that you don't need it. You should memorize this one, okay? So, what is your quadratic formula?
Negative b.
X is equal to negative b.
Plus or minus the square root of b squared minus 4ac over 2a.
That's it. Good job. Okay? Guys, when you first get your test, before you do anything else, why don't you write that on the front of your test? Can you remember to do that without me reminding you here? Somebody remind everybody in class, write the quadratic formula down, okay? All right, maybe I'll put it on your sign-in sheet. Write the quadratic formula the first time when you first get your test. Okay, so all you have to do now is say what's A, what's B, and what's C. Well, A is the coefficient of the first term, B is the coefficient of the second term, and C is the coefficient of the third term. Now all we've got to do is plug it in, right? I'll come over here so I've got room. I'm going to say negative B plus or minus the square root of B squared minus 4 times A times C, and all of that is over 2 times A. Okay? And then you start, this is where I say it's got lots of error, it's error prone. Okay, here is negative 6 plus or minus. Let's see if we can simplify what's under the radical. I've really got 36 here, right? If I do it here, I'm going to say 36 minus 100, isn't it? Isn't that right? So 36 minus 100, if you take that and subtract it, you're going to come up with a negative number. Negative 64 is what I got. And all of that is over 2a, which is 2. Well, you should look at negative 64 and say, what are you going to factor out first? An I, right? Because negative 64, remember, is really negative 1 times 64. When we pull it out, we pull out an I, and this is a perfect square, 8. So this whole thing right here becomes 8i. All right. So I've got a negative 6 plus or minus. Well, that whole thing resolved to 8i, didn't it? All over 2. And now, whoops, sorry, can you reduce it? What do you reduce it to? Negative 3 plus or minus 4i, right? These both will divide by 2. When I divide them by 2, I get rid of the denominator completely. It became whole numbers, negative 3 plus or minus 4i. Okay? All right, next one, quadratic formula to solve the problem. But this one has a little catch to it. There's a fraction in the equation, and you don't want to do the quadratic formula with fractions. You want to clear the fractions first. So I'm going to write this again just so that you can see what I'm doing better. And I'm going to put some space in here. And I'm going to clear it by multiplying it by the least common denominator. Well, the only denominator is a 5. So I'm going to say this times 5, this times 5, and this times 5. Every term has to be multiplied by the same number. That way we haven't changed the equation at all. When I multiply those, I cross-reduce and I have x squared. Over here, I have 5x. And over here, I have 45 times 5. Well, that's 225. Calculator, right? And now, you got to get everything over to the same side, and you want to go to the side where you have your x squared, right? So I'll subtract 225 from both sides. So I got x squared plus 5x minus 225 is equal to 0. And now I'm ready. A is equal to 1. B is equal to 5. C is equal to a negative 225. I'm not going to have some easy numbers, but that's the way it works, right? I say x is equal to b squared, negative b plus or minus the square root of b squared minus 4 times a times c. Whoops, negative 225, right? Don't forget that. It will change it all. So I got a negative times a negative here is going to give me positive, isn't it? All over 2a. So what am I going to have? X is equal to negative 5 plus or minus. And this is really going to be if you want to do it, oh, I'll just write it down. 25 plus, because it's negative times negative here, so I'm going to say this is really 25 plus 225 times 4, which is 900. Are you getting the same numbers I am? I'm kind of going back to my notes from last night, and it was late when I did this. Okay, simplify it again. Let me just go over here and do it. This is equal to a negative 5 plus or minus the square root of 925 all over 2. And you cannot leave it like that if there are any perfect squares inside 925 and you know there has to be at least one. Why do you know there has to be at least one? Yeah, it ends in 25. Anything that ends in 25 or 50 or 75 is divisible by 25. Think about money, right? Think about that being $9.25. You could divide it into quarters, couldn't you? And we know a quarter, 25, is a perfect square. So I'm going to come over here and I'm going to go 925. I know I can get one perfect square out of it, 25. And when I divide 925 by 25, what did I get?
37.
Are there any more squares in this thing? Factors of 37 that are perfect squares. Anybody? Okay, I didn't see it either. So really what this is the square root of 25 times 37. This one can come out as a 5, and that one has to stay. So I'm going to write it again. Negative 5 plus or minus. The 5 has to be multiplied times the radical. What's left under the radical is a 37. What's left in the denominator is a 2. And then you look and say, can I reduce? Do you see any way to reduce it? Anybody? 2 will not divide into 5, so we're stuck. Are you good with that one? Okay. All right, next. Page, last page, right? Okay, so instead of the other one, which was the square root property, which we were taking the square root of both sides, we're going to do the opposite of that now. We're going to square both sides to solve these, okay? It does not require you to do the plus or minus thing when you're squaring both sides, okay? What it does require is this step. Do you see it? It's in your instructions. Don't ignore your instructions. You won't get it if you don't finish the problem, okay? So you have to check these. First, I have to have the square root on one side. I've got a negative 5 over here messing me up, so I'll add plus 5 to both sides and get rid of it. And my problem becomes the square root of 8x minus 7 is equal to 5. And then I'm going to square both sides. How do I get rid of that radical? I have to square it, okay? Square both sides. I now have 8x minus 7 is equal to 25, and this is a simple one for me to solve. I will add 7 to both sides, and I have 8x is equal to 32. Well, that made it really easy. Divide both sides by 8. 8x is equal to 4, and don't forget to check. So we go back up here to the original problem, and wherever there was an x, we're going to plug in a 4. 8 times 4 minus 7 is under the radical, minus 5 is equal to 0. If we have a true statement, then our solution worked. So what's this? Well, this is really the square root of 32 minus 7. Minus 5 equals 0. 32 minus 7 is 25. Minus 5 equals 0. The square root of 25 is 5. And when I get here, I'm done, okay? 5 minus 5 is equal to 0 is a true statement, right? So our solution of 4 worked. You good with that? This is simple compared to what we've been doing, isn't it? Next, solve and check. Yeah.
So my math lab, I forgot what it said exactly, but is it whenever there's a negative behind the equal sign, it's not a true statement?
Say that again.
Is it that whenever there's a negative behind the equal sign, it's not a true statement?
And there's a negative behind the equal sign. When it comes to, is it behind the equal sign? Or
If like, let's say it was 8x minus 7 and then equals
negative 25, it's going to say it's not a real number, right? I think is what it says. Okay. Which square root of a negative number is what you'd be taking, right? You're squaring a negative number, and then you would have to go backwards to check it. I think that's what it's saying. I think you'll find that these are going to help you with pretty much like your test is going to be. So I wouldn't worry too much if that's got a confusing problem in there. All right, let's look at this one. For this one, I'm going to square both sides. Well, it's already, the radical's already on one side, and just the 5 is on the other, so all I have to do is square both sides to fix it, or to solve it. I end up with 3x minus 2 is equal to 25. Add 2 to both sides. And 3x is equal to a 27. And then when I divide by 3x is equal to 9. Okay? These are simple. I'm going to come up here and I'm going to say 3 times 9 minus 2 is equal to a 5. And that's going to be 27 minus 2 is equal to 5. And that's going to be the square root of 25 is equal to 5. Now, at that point, I'm good. If you leave it there, because you know that the square root of 25 is equal to 5, right? Are we okay? So our solution worked. All right. Now I have a word problem that you do need to know how to work. This is not hard, but what you're going to have to know is the second formula. Okay, the first formula you have to have memorized. This is the quadratic. You got that. The second one is the Pythagorean theorem. Do you know what it is? Remember this one? Exactly. The Pythagorean theorem has to do with right triangles. Okay? In other words, I've got a right triangle when something has the two sides of it form a right angle, you know, a 90-degree right angle, perfectly perpendicular to each other, whatever you want to think about it. And one of these sides, the short sides, is A, and one of them is B, and the long side, the side opposite the right angle, is C. The only requirement here, guys, is that the side opposite the right angle has to be C. The other two, it doesn't matter which one you make A and which one you make B. And the formula is A squared plus B squared is equal to C squared. Okay? So for this one, you have a tree house. It's 36 feet high in a tree, and you want to slide to end 15 feet away from the tree. It's almost like, okay, I made this problem up, and it's almost going to be like these kids are going to come down a pole because they're going to come real fast. This is a steep descent they're making, but oh well. So I got a tree, right? Tree. And here's the tree house up here somewhere. Right? There's the tree house. And I want to make a slide. Well, I'm going to say, okay, from here to the ground, there's the ground. From here to the ground is my side that's going to be, how big is it? 36, right? That's a 36-foot high tree. And I want this part where the slide ends, I want it to be 15 feet. Where's my slide go? Like I told you, a really steep descent here. So this is A, this is B, and this is C. I don't care which one's A and which one's B. I simply need C to be the unknown side. So I'm going to say A squared plus B squared, well, A squared, it would be 36 squared, plus B squared, well, that's going to be 15 feet squared, is going to equal C squared. Now, at this point, you're going to take your calculator and say 36 times 36. You get 1296. And you're going to say 15 times 15. You get 225. That has to equal C squared. Well, I'll add those two together, and I get 1521 is equal to C squared. And here I'm back to, okay, I can take the square root of both sides, right? Now listen, typically we would put a plus or minus over here, right? Wouldn't we? But is this ever going to be a negative distance? I mean, the slide is never going to be a negative so many feet. So the plus or minus thing is not practical for this problem, is it? So you really don't have to have it this time, because you know it has to be positive. You know your answer has to be the positive one. We take the square root of that one, and we take the square root of 1521. And when you type it into your calculator, you'll find that it's 39. Now, here's the other thing. Is it feet or square feet? Feet, thank you. A length is always linear feet. It's not square, it's not area. Area is the square. So you have to put that down, okay? That it's feet, right foot, FT if you want to, okay? But that's a problem you need to know how to work. So you got two formulas. You've got the quadratic, you've got the Pythagorean theorem. If you are iffy on formulas, then the first thing you do when you get your test on Monday is you write down the formulas, okay? I would definitely write the Pythagorean theorem,
I know typically we do, so for the test, would there be instances where we need to?
Say that again?
Would there be instances where we need to use a plus minus for the test?
There will be some where you have to use the plus or minus, like the previous problems we went through. But if you have a word problem, your answer is never going to be negative, okay? You would only have the positive solution. If it's length is what I'm saying. If it's length you're getting, or even if it was area or something in a word problem, the negative answer doesn't help us, okay? All right, guys, I will see you. I will not see you on Monday. I will see you on Wednesday, okay?